Hi, it's Gadget UK here again. As you can see, yet another Neo Geo. I promise we are getting to the end of these Neo Geos. I think this might be the last one. So you can see really bad corrosion there actually. It might just be some oxidisation, but there's certainly some corrosion around the chip there that looks like the clock chip, the real-time clock chip there, 4990. So I'll remove the screws and we'll have a quick closer look at the board, but this is the size reduced version. It's one of the last revisions of the Neo Geo. This is a 1B. The only one that followed this was a 1C, which I think reduced the chipset slightly further. So I removed the 4 screws. I'll show you in a sec where they go, perhaps when I reassemble it, from underneath that hold the housing on top. So you can see how dirty it is and oxidised. I mean, look at the contacts here around the battery, and you can see the connections there. That might be the HC32. I'm not sure which one of those is the 4990 and which one is the HC32, because they're just, it's just covered in dirt. This, you can see there's been some repair previously here with some wires on the RAM. That's interesting. Look at this down here as well. What on earth's happened to the side of the CPU here? It's like one of the pins looks a bit questionable. We've got a floating wire or something that someone's stuck on there, but that looks like that's happened a long time in the past. Look at the crystal. Someone's cut the crystal strap there for some reason. I'm not sure why. Neo-Buf chip. Now this was my first thought when I saw this. I saw these 2 Neo-Buf chips here, and I wondered if one of these was outputting when it shouldn't do. And would, if it's on the data bus, it would, in theory, kill the data bus. So you never know, that might be the actual fault with this. From what I understand, the way it was described is it's displaying coloured blocks, and that's what you'll get with a Watchdog. Presumably it's ticking and you're getting coloured blocks, but we'll find out. Look at the corrosion here as well. That's awful, absolutely awful. Look up here, horrendous. But this may be one that I can't fix. I'm coming into this video here thinking actually there's more chance of this not being repairable than repairable at this point in time. And the reason being is obviously you've got a lot of consolidation into these the 3 main chips, or 4 main chip, well that's just a ZMC2, the 3 or 4 main custom chips here, these 3 can only get on a 1B. You might be able to get the smaller ones off one of the others. Maybe this is on a 1C, I don't think so. It's looking pretty dirty up here around the Z80 area as well. The ROM on these is surface mount. That's the other thing that makes these a bit more challenging. I did start, I haven't finished it yet, a design of a socket that would fit over here and give you a DIP 40 socket on a PCB, so you could remove that or bypass it on the board and replace it with a DIP IC. So I might do that. That might be the second part of this video. I'm not sure yet, but at this point in time I think I'm going to I'll test it, I'll show you what it's doing, then I'll go around and clean up with cotton buds and IPA and stuff. We'll see if we can clean up some of these connections, see if we can improve them. You can see how bad they are. I'm not sure whether it is just dirt and dust and oxidisation or what, but yeah, some cleanup work is required. On the underside we've got another fixed wire here, and again it's just looking very dirty. Something up here, is that damaged trace? I'm not sure. Got lots of dirt around there as well. I'm amazed how dirty this has got. I don't understand how it gets so bad actually. Someone's burnt off or ground off the serial number there for one reason or another. But it looks like all the components are intact, and I don't actually see a massive amount of rework other than the sort of fudgy connection here and the couple of wires you've seen. Maybe the backup RAM's been swapped out for a previous failure in the past. Look how dirty it is around the crystal here. Look at that. It's horrendous. So when I first powered it on here, it was making an awful sound actually, like lots of noise, and it was a case of just tweaking the pot there. I found that on all the other MVS boards I've been looking at recently, that when you get dirt on the pot, it just picks up interference. So you can see we are getting a Watchdog there. Click, 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 click. But we've got lines coming down as well, so I would think we've got 2 faults going on here. Something's killing the system, stopping it from booting. Something's affecting the video output there. Maybe the ZMC2 on there, although that only relates to the cart data usually coming in. So I don't know, the GPU side of this could be faulty as well. So anyway, I think, like I say, I'll clean up the board next. Let's just clean it up and inspect it and see if we can see any physical damage anywhere that might account for some of the things we're seeing here. So initially, it's just cotton buds and IPA, but I will get the fiberglass pen onto these areas of corrosion, because the cotton bud on its own is not going to do anything. And if it is corrosion rather than dirt, you know, we may have to do a lot more work, and it may well be beyond. You know, if this custom chip here has got a fault, it's going to be game over. But it was quite cheap, this board. It was like £15 or something, so I can always use this for spares. We can always try and get another 1B at some point in future, and then maybe revisit if I can't get this working in this video. Well, we're just a few seconds into cleaning here, and I think I might have found the faults already. Can you see? I'll try and get the cotton bud into shot. Tip of the cotton bud here. See the black traces here just come down that area there? Yeah, we might have some missing traces. I will certainly have to reflow this side of the chip, get some flux onto it, but before I do that, I'm going to use the fiberglass pen very, very gently, because if the corrosion is eating into the tops of these pins, you could very easily pull these pins off the package. The last thing I want to do is have to Dremel the top of this to expose these and try and solder little wires and things on. I'd like to try and keep that in one piece. I think for the most part, there's just lots of dirt. There's just a few areas like that chip where corrosion has definitely you know, been a factor. I think it's more dirt than anything in the rest of the board. This area here on the CPU will obviously need some more work, but and this chip here at the bottom of here as well. Pins there aren't looking great, so we may have a damaged trace there. And as I said right at the start, the Neo-Bufs might be the reason we get a Watchdog. The video issue could be, I suspect the video issue might be caused by that, and I suspect the Watchdog could be one of these Neo-Bufs. Depends what those Neo-Bufs are used for. You know, if let's say if one of them was on the prog interface, like the GA11 position on an MV1A or 1AX, then yeah, it's kind of a suspect, key suspect for data bus faults. So it's a little bit cleaner here. I'm just going to go over this with the fiberglass pen now, and just see if we can get this area looking a little bit cleaner, both on the PCB and on the edge of the chip there. Any of the bits of corrosion will do the same thing, just so I can see what's going on. So you're not going to be able to see this until I put you on macro really a bit later, but I've cleaned up around here. Can you see we've got some bare copper there now. There is a couple of connections there that look awful on that 68K, so we might have a damaged connection there. That might explain the Watchdog. It's still pretty dirty. Here, again, I've cleaned up a lot with the fiberglass pen. We've got some exposed copper there where there's been some corrosion, but the traces actually look okay. But the top of this one here, the corrosion was quite extensive. I've not shown you, but what I've done is, you know, use a pin or something and get onto the top of the pin and just, you know, the very edge of the package, just scratch a little bit, just very gently, and the stuff comes off. The fiberglass pen wasn't bringing it off. Then go over with the fiberglass pen, and it was a similar sort of thing over here. You know, to expose these bits of copper where the corrosion was on the silk screen there, I've just, you know, and the solder mask, just scratched, just very gently. I've not touched this area with the tool yet. I've just used the fiberglass pen, but as you saw in the macro, we've got a couple of dodgy connections. One of them looks like was originally patched a long time since. That's, you know, it looks like that's been on there for ages. And I suspect this has had some corrosion. Someone's just bodged these two wires, got it working, and put it back into service. They haven't done any other clean-up work. They haven't dealt with the corrosion. Maybe they never even swapped the battery. I don't know, because that doesn't look like that's ever been replaced to me. I'm going to remove the battery next. The connection here connects, the one that's broken, I think, that needs a wire, connects to these rams here. I'm guessing this is VRAM related. That might account for the stripes. You know, we saw a pixel width or so of stripes down the blocks there. So I'm going to deal with that first, then we'll test it. Hopefully we should still get flashing blocks, but we might have solid flashing blocks rather than the stripes. I'll then focus around here, do some connectivity tests and see if I can follow the traces. This 68K, you know, it's PLCC, this, it might need to come off, might need to use the hot air and remove it to inspect underneath it, because there's no telling what actual damage is here, because as you can, well, you can sort of see, it's really hard to see what's going on. There is a trace here that comes up to what looks like that third pin, so I can test that, I can follow it, see where it goes to down here, measure continuity, see if we've got a connection there. But beyond that, you know, underneath here, we don't really know what's happened. And again, coming back to what I was saying, we might have a data bus problem, and it could just be Neo-Buf. We can remove, I'll see what that is. If it's on the data bus, we could just remove it, and in theory it may boot. We may get an error or it might just give us a crosshatch. But we'll deal with this first. Let's just take this step at a time. We'll deal with this first, see if we can deal with the line issue. So surprisingly, these dark traces here are actually making a connection. I would reinforce them myself, or at least scratch them back down to copper and coat them with solder later. The one that appears to be broken, I can't quite see, I think it's this one here. Yeah, I think it's that one there. It doesn't look it, but I've measured on continuity and there's no join from the pin here to that via. So that appears to be where the break is. I think just at this stage I'm going to solder a piece of kynar or coil, I'll use coil wire, it's smaller, onto that and just reinforce that. In fact, you can see it there, you can see it's a bit black there. I think it's the pad end, there's a break. So we'll join that up and I'll test it. Before I do that though, I'll get the, sorry, we're a bit close there, the fiberglass pen. You can see someone scratched this sideways. Can you see the sideways scratches? But we'll get the fiberglass pen onto there and just clean that up as well on both sides before I test this. Yeah, it's like we're not getting a Watchdog now. No, we've still got the lines, we've still got a clicking, but there was definitely a broken connection there. So the other thing I've just done is measure connectivity from the ROM here. Now this has got the same pin out as a 27C1024. So the first data bits, I think you missed 2 pins here, or is it you missed the end one? I think you missed the end one, and then you've got like data bits all the way down here, all the way up to like third from the end here. I think Q15 ends up as pin 3 actually. And I tested continuity from the first data bit, and lo and behold, we landed here. And then I did the second data bit, and we landed here on this Neo-Buf. So this is what I want to check to see if this Neo-Buf sat on the data bus. So whilst that might not be the fault, and I haven't scoped anything or done anything else, I did some connectivity tests here. I couldn't see anything wrong with the connections there, although underneath we can't see. I checked all the connections here, that's all good now. I'm going to remove that just to rule it out, divide and conquer, because as you'll see, or if you've seen in the MV1A /AX videos, these are a pain in the butt and can often fail in such a way that they output to the data bus when they shouldn't be doing. Just like a 245 does actually, like it did in that BBC video we had there earlier in the year. So I'll remove that next and we'll try it without it. So we're supported off the floor here. I've got some Captain tape around the dip switch there just to protect it a bit. Try and get on under the very edge there. Again, I've covered this in previous videos, there's nothing rocket science about this. Now this is a long shot, but it is worth, I think it's worth at this stage just to rule it out. Because I think, in theory, it should still boot without this. Looking at the top side, you know, the top board there, I don't see this being used for anything other than perhaps passing the data bus to the top board. But again, I've not tested any connectivity there other than just the connections to the data bus. You know, so I do know it is connected to the data bus, 68K. And it'd be super nice if it sprung to life after we remove this, but I seriously doubt it. And we do still have those lines coming down the display there. It might be an idea to remove that dip switch actually. I can smell the plastic heating up. I'm not very happy about using hot air so close proximity to it. Yeah, I can feel it starting to move already actually, that. You can hear it squeaking, hear it clicking there as it reaches temperature. It doesn't take very long to remove these. You've got to be careful. The last thing you want to do is lever the thing off, you know, because any pins that are still gripping the solder there, where the solder's not molten, it'll just break the trace. But yeah, that is coming off a lot easier than I thought it was going to do. There we go. Look at the dirt underneath it. Can you see that? Horrendous. I might end up removing a number of chips from this board just to see what's going on underneath. I mean, that's a classic example there. We could have some broken connectivity around that. Let's give that a try without that chip on. Whoa. Yeah, so we got some progress there. That's supposed to say work RAM test. Now the interesting thing is the dip switches are not set, so I'm guessing that Neo-Buf is something to do with the dip switches actually. But the fact we've now got some life out of it, the colours aren't quite right there. And obviously we've got these stripes down the screen. If I could solve that stripe issue, that might account for it. Because if you watch, just watch, it's super quick in terms of the boot process there. You know, you get that green, you know, you see the green screen that actually goes green, then with those blocks down there, that's normal. So that shows us the BIOS is okay, 68K is okay, it's going into the work RAM test. Now that's not erroring, that makes me think the work RAM is probably okay. What I might do is just clean up around this now, get out an alternative Neo-Buf on here. I've got some of the ones from Furtek, I could put one of those on there. The other thing I could do is I've got an actual Neo-Buf, I think, that I took off one of the MV1A boards where I swapped over for the ones for Furtek on the other videos there, the other repairs that you may or may not have seen yet. So I could stick an alternative Neo-Buf on, you know, clean up the pads there, remove the solder, I'll show you my fitting replacement Neo-Buf. But my instincts there were right, actually. I think the Neo-Buf is a huge part of the problem. I suspect if we replace that Neo-Buf, now what we're going to see is the system will work, hopefully we won't get any sound issues, but we'll have these lines. You know, we've got blue lines down there where we shouldn't have, I think. You know, the pallet's wrong as well, that could be indicate another fault. Maybe there's a problem with the pallet RAM on this. I don't know whether the pallet RAM's external. Is that what the two RAMs were there that are connected to the large quad flat pack, you know, with the damaged trace? I'm not sure. It could well be a fault internal to one of the chips. You know, we may have some faulty internal pallet RAM or something. I'm not sure whether it's merged in or not. But we did learn a number of things by doing that. You know, like I say, we know the backbone of the system is okay, you know, because it is able to run the code from the ROM here. It did go into the work RAM test. If there was an error, that would have popped up straight away saying work RAM error, and it probably would have given an address. So that shows that kind of this stuff here is alright. The backup RAM we don't know about yet. The ROM is alright. We do know that we're getting some video output, so probably the backbone of the video system is okay. We've got lines down it, that could indicate a fault internally here. But I'm thinking maybe one of these is faulty. Maybe because the connectivity was faulty here, we've still got a damaged connection, because can you see down here, this looks quite questionable as well. So yeah, I'm sort of thinking around there. Still could be another bad connection because there's a lot of, I don't know, you can see, still could be a bad connection because there's a lot of, you know, dull traces there. There are lots of places on the board, like here, where you can see like little black marks, you know, so we could have a broken connection for the RAM there. But clockwise, it looks like we've got the right clocks and things, I would think, because we wouldn't have got this far into the boot process. So I'll clean up around here. I'm going to use cotton buds first of all to get rid of all this muck off here, then get some flux on there, desolder braids to clean up the pads, and I'll just clean around there with cotton buds and stuff, and I'll show you as we make progress at the various steps of cleaning that up. But I'm just going to go very gently, because remember we've got solder, sharp solder edges on the pads, so I'm just going over the black areas there where it's really dirty. Just gently over the pads, not with much force at all, because last thing I want to do is damage it. The key really is going to be to get the solder off there. Once we've done that, it's then easier to clean with a little bit more force. But at this stage, I'm just trying to get as much of that as I can off there before we start trying to solder and, you know, add flux and stuff, because it'll just get really messy really quick. So we'll get a bit of flux. We don't need masses, just enough to help with the braid. I need to get a new reel of desolder braid because I've used so much of it on Mike Pearman's MBS boards. So we'll just gently, like I said, just go over this with the desolder braid. Absorb all those sharp solder edges. I tend to go over this twice. You know, you go with the first time like that and you've still got big lumps of solder. And you can see, you know, it's absorbed a fair bit of solder there, so cut that off. And repeat, get a bit more flux on there. And then we should get a nice, flat, smooth surface. There we go, that's what I'm going for. Obviously, the less time you heat this, the better. these pads are super susceptible to too much heat. Might go with that a third time actually, because there is still a fair bit of solder on there. It's not too bad now, I think we're nearly there. Anyway, you get the process, rinse, repeat, do the other 3 sides. So there's a part way cleaned, just cleaned all the flux off there. I'll go over that with a few more cotton buds and IPA now, try and get that whole area super clean. So there we go, that's about as clean as I can get that area there. I've used the fine tool here just to scratch a little bit of the corrosion off the top of the traces there, but they look okay. I can drag some solder and solder braid on those after. I might remove the dip switch first before I do that, and it'd be useful to see what's underneath it actually, because you saw how bad it was here. There was tons of black stuff underneath it, but the pads look okay. I don't see any broken connections there, so I'm going to get one of the, let's say the Neo-Buf chips that I think work on there, and then we'll give it another try. So I'll try and anchor this while you watch. It's not always that easy to do, because you only need to touch the pin and the whole thing moves. The easiest way to do it is use a load of solder. Just try and get it to flow onto that one pin like that, and then just do the same thing down here like that. Press it down, reflow, hold it, same thing down here, and then just inspect. Ignore that giant blob, we're not worried about that. Yeah, that's nice and straight aligned, so we'll get some flux on there again. This tube's nearly out actually. Get some fresh solder on the tip. And I'm going to dab into these to start with, until we got rid of that massive lump in that corner there. Yeah, I can remove the excess in a sec with some braid. Yeah, see if you can see the side a little bit better, but you can literally just, drag over these, but you will end up with a lump in one corner if you've got too much solder. That's not too bad. The reason I always go up and down like that afterwards is you just get a cleaner connection. So I've got some more solder. I'm holding the board up off the mat. Yeah, I'm not on the carpet here, I'm actually on the edge of the mat, but I'm just holding it up just to show you. But yeah, that's it, I think. Yes, the final side was a bit of a pain because it's right next to the dip switch there, but it was okay. There is enough clearance, and as you see here, just use a bit of the solder braid to remove that extra solder, and then just give it a bit of a flow to make sure you've got enough solder there. But that's it. I'm going to give that a try, and then I'll clean it up. So that's with the replacement Neo-Buf on, which is not positive actually, because the dip switches in either position are not influencing it going into the work RAM. I need to trace those to see where they're going, but I'm guessing that Neo-Buf. So either the Neo-Buf put-on's got an issue, which I don't think it could have, or we've got another fault on the board here. We can't get it to go out of work RAM test. Let me see what happens when there's a carton there, just out of interest. Yeah, even with the carton, it goes straight into the work RAM test. But I'm sure this has got nothing to do with it, but if I just measure dip switch 1, continuity, well, two's on, right, 1, about 470 ohms or something. All the others, we get a short when they're on. I think, yeah. So I'm not quite sure why dip switch 1, hang on, that one's not, oh yeah, that one's alright. Yeah, I'm not quite sure why dip switch 1 is measuring 470 ohms, that's a bit strange, actually. I'm just not sure if it's got some corrosion or something inside there, or whether that indicates something else, I don't know. Like I say, it might be wired differently or something, but I'm assuming that what's happening here is these are just, the other sides of these are just connected to the Neo-Buf. Now, there is a chance that Neo-Buf I've put on there is not right. I'm not 100% sure. I just suspected it was okay when I took it off. But it may well not be. I might just get one of Vertex boards on there actually, just to get it up and running. Yeah, so we'll just dry that off. And we'll just see if that's made any difference at all to the measurements. It's a bit crazy this, I think I need to do the others, because watch what's happening now. That first one, we got short when it's switched on, that's good. Next one down, now we got a resistance. It's shifted down, that one's alright. That one's alright. That one's got a resistance. That one's alright. That one's alright. That one's alright. So we've got 2 or 3 others now that are playing up. So yeah, I need some contact cleaner. I'm going to need to mess around with that for a bit. Right, slow but steady progress. We got the crosshatch up. Switch it off, I'll show you something. Now this confused me for a second. You'll see that we get work RAM test, and then it goes off. I think that's normal. I think the BIOS on this is subtly different on the 1B. I think it goes into that work RAM test initially. I'm guessing if I switched all the dip switches, in fact the dip switches were all down, so maybe it doesn't stay in a looped test, I don't know. Let's switch them all in the other position, let's see what happens now. Let's see if it stays there, or yes, it's, oh hang on, no it's not. So I don't know, I'm confused by that. Totally confused, but the dip switches were part of the issue there. Let's try a cart in it, because I am curious to see if the game actually works. Well, that's interesting. Why have we gone to this? This is the Asia one. Let me scroll a bit. You can just about read the fonts. It's not, 100% visible, but Neo Geo MVS system Asia version 6. Hardware test, setting up the hard dips, soft dips, bookkeeping. Let's just use exit. See, it says switch 1 off. Is it on or is it off? I don't know. Maybe there is a problem with the Neo-Buf here. Maybe that's why it's behaving this way. Is there a sound test built to this? You can play the backup. It says press A, B, C buttons one at a time, I think. Oh, at one time. Yeah, I swapped out the Neo-Buf chip a second time, and I'm glad I followed my instincts there, because it turns out that that chip that I thought was alright, I wasn't sure, it was suspect, yeah, it did have a fault. So this is with another Neo-Buf chip, and it goes straight to the crosshatch. No work RAM test or anything like that. Great. So I'll stick King of Monsters 2 in, and let's just see what happens. It might not boot, we might get problems, I don't know. Just be interesting to see. Wow. Now bear in mind, I'm expecting those little lines. Let's just adjust the volume here if I can. The sounds are awful. We're getting some PCM issues, aren't we, I think. Surprisingly, the graphics look okay. I think that's a PCM issue we're hearing there. I'm forgetting, it's not a unibar, so I can't press the select button. Let's put a coin in. So let's just ignore the sound issues for the moment. Seems to be working alright, doesn't it? Let's just test the directions. Yeah, that's working. So I think what I'll do next time is I'm going to clean up the cart bridge, because it's got some awful looking oxidisation. I'll show you in a sec. But it may well be that the sound issues, PCM issues, because the PCM bus is not making a good connection on the cart. Yeah, so if I show you the bridge here, sorry the light's going off in here, it's going pretty dark at the moment. Can you see? They're just like black. They shouldn't be. So I'm going to clean up you know, both sides here to make sure they're okay, and also clean up these as well. Just, you know, get some IPA in there, toothbrush, brush, inspect with some light and magnification at an angle to see if you can see any corrosion on the, you know, the nice gold plated connectors there. And I'll clean up the slot as well with some paper. Just fold some paper 2 or 3 times, dip it in IPA, and then push it in and out of the slot a good 10 to 20 times, as you've seen me do a number of times in videos. But we do have a Neo-Buf here. I'm not ruling that out yet. That might be something to do with the problem we're getting here. Although I'd be surprised if the PCM audio goes through there. You know, I think not. I think it's going to be direct connections here. We could have a bad connection on this board. I mean, that YM2610 looks dirty as anything there. You can't really tell on this light, but yeah, you'll be able to see tomorrow in the when it's a bit sunnier, hopefully, the issue there. Some of the solder points around here don't look great on the ZMC either, but obviously that's got nothing to do with the audio. So the one thing that is confusing me at this stage, that's kind of unexplained, is those lines. Because as you saw, when the game was working there, we didn't have any lines at all. That makes me think something to do with the fixed connectivity, maybe? I don't know. But I mean, even in the S1 stuff, you know, the S layer, we didn't see any issues there. The graphics and the text and everything looked fine. It's just the crosshatch and stuff didn't, which is a little bit odd. But you can see how dirty this is. Look at that. It's black. This might be why we had that PCM issue. Shouldn't really go sideways, but generally with these, they're quite well separated with the little plastic dividers, so you can get away with it. Just be careful. So I'll use the dry end as well. Yeah, so you can see how much corrosion came out there, because that dark green, black, horrible marks. So I'm going to reconnect that and give that a try. Yeah, I think this solved the PCM issues. But can you see what I mean about the graphics? It's perfect. It's absolutely perfect. Yet when you try this without a cart, it isn't. That I find quite interesting, because that's not something I've seen before. Looks perfect. I'll show you now. Switch it off. I'll take the cart out and we'll power it back up and just watch. You'll see the lines. Look at that. It's very strange. That hissing, like I say, it's just the pot needs lubricating and it perhaps needs recapping. But I don't quite understand why we're getting lines down the display there. Unless it's something to do with whatever ROM it uses when it's, you know, you've not got a cart in. Is that the fixed ROM? I think it might well be. So maybe we've got a bad connection on the fixed ROM somewhere or something like that. So as it was going dark last night, I removed a 74 LS245 from the back plane, actually, you know, where the cart's actually plug into. I'll show you that in a sec. And the reason I did that is because it connects to the fixed ROM. And I suspected, you know, these lines, you'll see, something to do with the fixed ROM, because it's the only explanation. You know, with a game it works, and that fixed bus interface, it's 8-bit, as far as I can see. In fact, it is, yeah, it's 8-bit, and the cart obviously connects to that. So the fact that the graphics in the game work okay shows that when the fixed interface is used for a cartridge, everything's fine. Now that's a good indication, because that kind of shows me that the graphics chip, the GRC2 there, has not got faults or a bad connection on the, you know, that fixed data bus to the cart. But on that cart bridge, right next to the cart connectors, like I say, is a 74 LS245 and the fixed ROM. And I suspect, well, I don't suspect, I measured connectivity and I found connections between the 245 and the fixed ROM. So I wanted to rule out the 245. Which means if we boot this with a game now, you get no graphics at all, but we've still got the dash lines without the 245. So I've ruled the 245 out, which I'll show you in a sec. The only thing that I can think of now is the fixed ROM, actually, unless we've got a missing address line to the fixed ROM on the board I'm about to show you in a sec. Yeah, so I gave the board another quick clean last night. It still obviously needs a lot more work, but it's looking a lot cleaner already, actually, just from the bits of work I've done. So you can see on the back plane here, I removed that 245 there. I mean, it says LS245F. It was just literally a 74 LS245. It didn't have the F suffix at the end there. But I measured, you see the wires along the bottom there, that's the data bus. And I saw it goes all the way down here to here, but it also makes a connection over here. I think it may well be that this 245 gates the access to the cards. It looks that way. So, you know, that's not like the data is passing from here through this. But what sometimes happens with these is, you know, in one direction, what, you know, it starts to output and it shouldn't be doing. If you see what I mean, it should be an input and it starts to output, etc. Or you start, you know, you get a constant stuck bit on one side. So that's what I want to rule out. And I thought, well, maybe, I don't know, the levels are stronger when this data coming through from the carts or something like that. So anyway, I wanted to rule it out. We've ruled it out now. It's just the same. I did quickly reflow this when I first got the thing here. When I focused on this fix area here. So I think the fix ROM needs to come off next. It just so happens I've got one of these spare left over from Mike Pearman's boards, actually. So yeah, consider that my payment for fixing all those boards. I'll remove that fix ROM, I think, and stick it on here. Before I do that, I think I'll just inspect. You know, we've got a couple of bad traces here, but I don't think that would cause it, actually, because we do know that the fix interface is going from the cart to here. Well, it might be here, I'm not sure which way it goes. Yeah, I think it's down here, actually. If you look at this, it goes here. So we know the data bus is there, it's going there. It's the address bus, I'm thinking. You know, if we've got one address bit missing on there, that might explain it. But then again, I'm not sure, because I suspect there's more than one pixel worth of data in each byte. There might not be. There might not be. Maybe it is this. Maybe like A1, you know, it starts at A0. Maybe A1 has not got a connection. So anyway, I'll have a quick look at that on the meter now and see if I can follow the traces. But it's quite hard because they all go underneath. I'm guessing they all come up here. It might be here. Like row of wires there. Yeah, they all go across the left-hand side there. So yeah, I'll check around there. Oh, is that a bad trace? Have I spotted it already? Can you see that? A little black mark there. Yeah, that might be it. There's some damage there, I'll show you in a minute, but I don't see a bad connection. I've measured around with the meter. I can't find a damaged connection. The solder points here look awful. Despite having been reflowed, there was a lot of oxidisation on this ROM. So I'm just going to swap it out and we'll just rule it out that way. If it's not this, it's got to be a trace that I've missed, but I can't see where. Hear it clicking there, just gently. Just the last few connections on each side here, and then it should free itself. Oh, it's really hanging on there. There we go. So you can see the corrosion that's occurred on these pads here. You can see on the very bottom they look dark grey, and it's the same at the top. The tops of them look awful. So I'll get the fiberglass pen on there next as well and just inspect around there, but I'm pretty sure that's okay. And you can see what I was talking about here. Some of these were black and I've just scraped off the top there with the fiberglass pen. Looks okay. I can retin these, you know, coat them with solder, stick a bit of nail polish over there to protect them, but and I have just checked these wires, because you can see those two there, those two are particularly awful and those aren't great, but they're all connected through to the other side okay. So It's got to be the ROM, can't be anything else. So I've swapped the fixed ROM, let's give that a try. Yeah, that's looking great. So it was indeed a problem with the fixed ROM. Sweet, that looks fantastic. Excellent. Let's try again. Yeah, it was just a dirty cart. I've not used this cart in ages. Should get some sound, I think, now. Sweet. Fantastic.
Hole number 1, 426 yards, par 4.
Player 1, tee shot.
Good shot.
So, mission almost accomplished. Just need to clean up now. You can see, you know, I swapped out the fixed ROM there, put the 245 back on. The solder points look awful on those, actually. I think it's primarily the flux that's making it look bad. But there's a lot more clean-up work on the board. I might just recap this while I'm here, because there's not a massive amount of caps to do. Yeah, I think I'll certainly swap out some of the main ones. There's some copper bits here that need desolder braid and solder dragging across them just to tin them. Same up here, we've got those ones there to tin as well. I'll get a few little bits of nail polish. You know, we put a little, I don't know if you can see it, I'll macro it in a minute, but that really fine piece of coil wire there to fix that broken trace that was connected to the VRAM here. We fixed that before it even sort of showed itself as a problem. I thought originally that was going to fix the line down the screen, but that would have resulted in the wrong sprites or incorrect sprites being displayed. You know, there would have been corruptions and things in them because we had a bit missing. Not sure if it was on the data bus or the address bus, but nevertheless that needed fixing. And because there's no other way to do it other than with a little wire on the top side here, once I've cleaned that up, I'm going to get a bit of nail polish over that, just so that doesn't get caught when you know, you use cotton buds and things to clean it. I'll do a similar thing with the bodge fix that someone did there. It's the same sort of thing. You know, they've gone straight from the CPU edge to a little wire there. So I'll do the same thing. You know, clean this up. You know, cover these copper bits here, and then encapsulate that wire with a little bit of nail polish. And then you know, just continue cleaning around. You can see we need to stick the crystal strap back on there. Need to remove the battery. That's an important thing. Should have done that right at the start, really. If you're going to work on a board like this, remove the battery right at the very start. Even if the battery doesn't need replacing, take it off there. You're best off not having any voltage on the board while you're actually working on it. But you know, it's been alright. The dip switches have been fine since I cleaned them up, but that, you know, that was definitely something that needed doing. Look at the underside. The underside is filthy. The underside needs a serious clean. There's a lot of muck and dirt on there. Look at it down here. It's really bad. So just cleaning up this board here, you can you see the bottom here? Can you see how shiny that is compared to the top and the sides? They're really dull. Yeah, just using a fiberglass pen to clean off the oxidisation, because as you can see, they're really oxidised. You know, there's a little bit of rust almost started there and on this top corner here. So yeah, got to be careful you don't get rust in there. What I'll probably do, and again it's going to sound unorthodox, get some WD-40 on a cotton bud and just gently wipe over these. Actually, it's a solvent, but it's going to coat the surface of these, you know, very lightly, just with the cotton bud. Like I said, there's hardly going to be anything there. just to stop them oxidising. Some deoxit might be useful on something like this, but yeah, you know, the technique, like I say, is just to, you'd be surprised, you don't have to do very much to get this oxidisation off there, but if we don't deal with it, it's ultimately going to turn to corrosion, and these custom chips like this are not going to last with a bit of corrosion getting into the package there. So I'm getting there with this board. I'm going to cover these with some solder next. You can see the one side of this Neo-Buf here I've not done. Can you see it looks dull compared to the other three sides there, and it's kind of greeny. So just go over that lightly with the fiberglass pen there. You can see very quickly it starts to look shiny again. But as I say, I'm going to go over the edge of these ICs that I do this on with a tiny bit of WD-40 on a cotton bud, just to protect them really. It'll clean them, but it'll also protect them. Yeah, so I got a little bit of WD-40 on a cotton bud here. Can you see the blackness that it brings off there? It does a fantastic job at cleaning things like this, actually. Yeah, there we go. That's looking pretty good now. So I'll just carefully drag the desolder braid over those traces to tin them where I've scratched them. You know, because they had corrosion on. It wasn't for testing connectivity. You can do that from point to point on the board. It's just where they've been exposed. There we go. I just need to inspect to make sure I've covered it all there, but that should do the trick, I think. So let's remove the battery. I should have done this, as I say, right at the start. That's what you should do. Don't work on one of these with a battery on it. As you can see, the desoldering station's been working perfectly since the review. No issues at all, no blockages, and I've used it an awful lot. Now we've got the battery off there, I can clean up around here a little bit better, and we can reconnect that ground strap. Yeah, it's freed up this area now, so I can have a really good scrub around here. It's particularly dirty around the battery area there. I'm not sure it's actually the battery's leaked. It looks like dirt and just like traditional corrosion, like, I don't know, it's been stored in a really damp location. What could have happened with this? It could have failed with the fixed ROM issue though, with the lines, and then it's just been put into storage. Someone stuck it in a garage or a loft, or, you know, warehouse or somewhere that's cold and damp, and, you know, that's where all this corrosion's come from. The dirt, no idea, must have been in a dirty environment maybe. And the reason I think that, with the battery leakage, you get green contacts rather than the dark black like they were on this. This is just like traditional rust. It just seems like it's been in a damp area. You know, can you see here? That's just rust. Those are rusted. I'll have to get the fiberglass pen onto that. I'll get the fiberglass pen onto these as well in a minute, because they're looking particularly corroded. To get into the nooks and crannies around here, I'll probably get some IPA on a toothbrush and just use a toothbrush to get all round that crystal there. But most of it's come off there, as you can see. So just cleaning in some of those hard to reach places, like in between the pins on this ram down here, because they're looking awful. Just toothbrush with IPA. You can see you can get right into the little gaps between the pins there. So I can use cotton buds to finish off, get around that crystal. But yeah, that's not looking too bad now. You can see I've cleaned up right here around the battery area. Got all of the corrosion off the little contacts here, off the crystal, off the strap. I've pushed the strap back together. I'll just get some solder onto the strap there to join it back up, and I might just pull the strap down a bit and just join it to that bit of solder on the can there. I think it should be okay. It looks like it's been joined there before previously, then someone's disconnected it for some reason. I'm not sure why. So you can see where I cleaned up the Neo-Buf here. That looks almost brand new. I haven't really done anything with these other than use the fiberglass pen and a bit of WD-40 just to protect it. I need to cover these bits here. There are a few little bits there as well, but I think what I'll do is just get the nail polish onto these little bits actually, to cover those over. I might put a little bit of nail polish on these wires here to secure it. I'll stick a label over here because it's a bit scratched up. I'll recoat these with fresh solder, the test points here for your ground and your 5 volts. So that's the top side cleaned up for the moment. I've removed all the hot glue off the top of these caps. It's never a good idea to leave it on there because obviously, you know, the vents have got nowhere to, you know, expand and explode the, you know, electrolyte circuit. You get a pressure build up in there as the caps start to fail. So I've always wondered why they stick glue over those. It seems a bit crazy because they will actually explode if the tops can't expand. You can see the crystal here. I cleaned up around it. It was awful around there, but I managed to ground that. That's okay. I got rid of all the gunk that was around here. You know, there was lots of muck and marks all over this board. It was horrendous. Whereas you can see now, it almost looks good as new. I need to clean this connector up here. Can you see the black, those connections there? So I'll do that next. But then I'm going to flip it over and do the underside, because as you can see, the underside is really dirty. It's awful. There's marks. I mean, look at all this black stuff here. It's gross. I think this has been in a chip shop, and the telltale sign is it kind of smells of fat, you know, chip fat, and it's like really thick, really hard to get the marks off it. So yeah, I think this has been in a chippy. I think what I'm going to use there is the wire brush, because that's heavily corroded actually. Yeah, the fiberglass pen on that is just not cutting it. Some sandpaper is another idea as well. The angle I'm at here, I can't get any meaningful pressure onto it, but the black marks, yeah, starting to come off there now. There you go, after a minute or two with a little bit of sandpaper, wire brush and the fiberglass pen, you can see that's come up pretty clean. And I did the underside as well. I padded this out with a piece of plastic underneath and then just went like that. I used an old credit card actually. It's in the other room at the moment, but yeah, just like that on both sides. Most of the corrosion came off just with the sandpaper actually. Surprising, the wire brush and the fiberglass pen, it did nothing, but that looks great now. So the actual repair has took very little time actually. The majority of the time I've spent cleaning this darn thing. So I think on the bottom side, rather than go with cotton buds to start with, I'm just going to get lots of IPA on there and have a really good brush around, you know, and then tilt it aside with a load of IPA and brush it off. And do this a number of times because there's a significant amount of dirt on this side. I might even just leave some IPA soaking on it in a few areas of the board there for a period of time before I start to brush it off, because it's really thick, you know, it's like I say, it's covered in fat or something. I will need to revisit the top side because obviously some of this is going to leak through the wires. That's the unfortunate consequence of doing this, but it will save me a lot of time I think doing it this way. Yeah, it's looking a lot cleaner already. You can see some areas here though where it's not shifting it. So I get a little bit of solder onto the copper bits there that are exposed on the battery contacts, you know, where I've cleaned off the corrosion. Then I'll stick the nail polish on, but as you can see, both sides are looking super clean now actually. Good as new, pretty much, well, apart from the odd wire. And you can see the colour of the board was here. Can you see that sort of browny yellow? It's, you know, it's just disgusting. It's all just leaked off there. Horrendous. Just testing with some Metal Slug 3. You can see, and here it's working fine. Obviously I've not started the game, so we've got no in-game music there. We'll stick a credit in. Just hit start.
Mission 1, start.
Yeah, sweet. So the shell's very scratched here, as you can see, but I've given it a light clean, you know, soap and water. I've used some plastics on it. You're never going to get all the marks off when they're this deep, you know, the scratches are this deep, but yeah, it's a bit cleaner. One thing I've noticed is the foot here is split. Can you see that? On one side, just on the top. So what I'm going to do is just get the mole grips, adjust them so they're the right size to hold this in place. Let's just widen that. I'll just show you, but just widen it like that and just clip it See that? That's holding that perfectly there. I'll stick some super glue in the gap, and then I've got some of these washers actually that I'm going to stick on there. These, they're not metallic, and I'm going to stick one on the top, one on the bottom with super glue, whilst the mole grips, you know, hold it in place like that. And that should just support that, you know, strengthen it. And then I've got some replacement feet, so I can stick some feet on this, and I'll stick the PCB in a minute and show you the final result. So there you go, you can see I've got the washer on top with the super glue. The super glue was in the gap there. I've tightened it with the mole grips, and we'll just leave that to set. I'll stick another washer on the other side as well. Yeah, it's a bit fudgery, but you know what, it's going to hold it together, that's the main thing. It should last then. So here's a final look at the board before I reassemble it. You can see I used a bit of nail polish there to support that. We tinned these connections here, you know, I tinned up any bits here that were exposed, and we've got, I don't know if you can see, we've got the smallest amounts of nail polish just where there were little bits of exposed things. You can see I coated those there and put a bit of nail polish over that. There's still the odd little bit of dirt on this PCB. And obviously I didn't get these pins super shiny. What I could have done here is reflowed, you know, got some flux and reflowed, but I think you'll agree that it looks leaps and bounds better than it was. And I'm not sure if I showed this on macro, but you can just about see the small coil wire there that went from one connection to via. And again, I've just put the nail polish there, not on the actual connection, so you can still measure around there. And you could always remove that. Same thing, where's it gone? Same thing over here, some nail polish on the exposed bits, and I think I replaced that wire with a slightly thinner wire there. When I come to test my ROM mod PCB, I'll probably need to redo this actually and move the wire a little bit further down, because it's going to need to clip on the sides there as much as possible, and whoever did this previously had a bit of a large solder point there actually. So we had some damaged connections here. I don't know whether I showed that, they were black. They were just black, so again, scratched them, coated them with solder, and then just put a little bit of nail polish over these points here. So, you know, it's in general, I think it's looking considerably better. It's much cleaner and more presentable than it was. Everything's looking nice and shiny. One thing I will point out, I had some Captain tape over here to protect this. At one point I wanted to test some of the Z80s from the repairs I was doing on Mike's boards. We ended up with seven faulty Z80s in total from 7 boards, so it was, every single one had failed. I think, was it 6? We had six faulty, but nevertheless I had to, you know, I wanted some way to test it, so I removed the one from here and tested them on this board actually, and as a result you can see it's just made a little bit of a funny mark on that there, despite having Captain tape on it. So that's one thing you can have a problem with these, you know, if you're going to put Captain tape over these plastic connectors here, if you're trying to move any of the chips near the back, maybe double, treble it up, you know, even pad it out with some foil on the inside or something like that, you know, so you have a big piece of foil there and then some Captain tape isolating the whole lot. That would perhaps be a good idea. We grounded the crystal there. I cleaned off some of the solder from here because there was a giant blob of it there, but at the same time I just joined the, in fact I put a new strap on. I took the old bits off and put an entire new strap over there, so that's that. And a quick look on the underside here, you can see it's super clean now. There's no marks or blemishes or anything, and we just used a little bit of nail polish here just to secure that wire. It doesn't really need it, but in general I think it's come out very well actually. As soon as I saw the Neo-Buf on this board, when it was advertised, I thought, oh, it's going to be that, it's going to be that, oh, it's going to be that, and lo and behold it was. So I'd suggest that those are common failures on these boards as well actually. The dip switches are working super well now as well. You know, earlier on we did have, when I was measuring across here, what you should measure is the 1K pull-up resistor on each one when they're on. And I was just getting 470 ohms, and then we tried to clean it up, and yeah, that solved this one, and a few of the others start playing. But after repeating that work with the contact cleaner there and switching them off and on a dozen times each, it was okay after that, and it's been fine ever since. So I didn't recap this in this video. I may well recap this maybe when I come to test my dip ROM adapter on here. I also put a little bit of nail polish on there. There's some scratches there. I can't do anything with those. The interesting thing is, they're like the sort of marks you see on a prison wall. You know, as someone counts the days, it's like you've got lines that way and then someone's put a line that way when they've gone through like a number of them. It's very strange. And the other interesting thing to point out here, I don't think you can just about see it, we've got someone's signature or something etched onto there. Someone's like written something on there. Can you see that? No idea what that says, but anyway, interesting. So you can see where I glued that foot on and put a rubber washer there on both sides, and that works super well. These feet have been on there for ages actually, and just because I need to put it in a small box actually, I've just took them back off, but I've got a full set of replacement feet there. You can buy bags of these off eBay, like a giant bag with 50 or 100 feet etc. in there with the screws and everything. So in terms of reassembling this now, just slide the housing back on, turn it upside down, and you can see we've just got 4 screw holes here for the screws. So the screws are a little bit weathered actually, you know, the tops of them are not nice and sort of shiny gold. As you can see, you know, they're a bit dull. I've cleaned them up as best as I can, but there's only so much cleaning you can do with things like that. So there we go, it's turned out very well. I'm surprised. I thought this was going to be one of those videos where I couldn't repair this system. In fact, I've got one of those videos coming up soon actually, 2 1F boards from my impairment I cannot repair at this point in time because I can't get hold of some parts. Anyway, we'll cover that in a future video. I do hope you found this interesting. Thanks for watching, and I'll catch you in the next video.